So this lesson is about inverse trigonometric functions, and what I mean by that is that this is about, things like the inverse sine of x, or arc cosine of x, or inverse tangent of x, or arctan of x. And in the calculus class, for pretty much all purposes, these are the same, right? Whether I decide to use the -1 notation or the arc notation, they effectively mean the same thing. They're both inverse trig functions. In math analysis, you may recall that there was a capital S sine and a lowercase sine, or a capital A arc sine or a lowercase a arc sine, and there was a difference on that one. The difference was that the capital one uses principal values and the lowercase one doesn't, not principal values. Like I said, in the calculus class, we pretty much use the top ones. There are some uses for the others, but I'll cover those when we get to those lessons. Before I get into computing inverse trig functions, I feel like it's worth talking about what they actually mean. And I won't take too long with this. And it's really kind of a simple thing. For instance, when I say that, where do I want to start this? I guess I should say this. When I say the sine of theta equals, A, what are these things? What manner of thing are they? And the thing I want you to understand is that when somebody says the sine of something, that thing should immediately be showing up in your mind as an angle. Regardless of whether it makes sense as an angle, when somebody says the sine of blah, that thing needs to be thought of as an angle always, in all cases, right? And whatever answer you get back, whether you use the unit circle, whether you use a calculator, whether you come up with some other method, the thing you get back is a ratio. And actually, in the case of sine, it's sort of the ratio of the opposite over the hypotenuse of some triangle somewhere, right? So how does the situation change when we are using inverse sine? Well, what happens, because it's an inverse, is that the two sides are being flipped. When someone says inverse sine of something, that thing is immediately to be considered a ratio. Just like we said, because it's sine, it's opposite over hypotenuse, right? And whatever answer you get back from sine is the angle that would cause you to have that ratio. And I'm of the opinion, and I've seen when I've worked with students, that if you can really wrap your brain around this idea, it becomes so much easier to answer these inverse questions, because you understand what you're looking for, right? In the previous two videos, when I've taught you how to find the sine of something, I've really tried to get you to think about that angle as an angle and to locate that angle and then look for the ratio, right? I'm really going to be doing the same thing over here. When I say the inverse sine of something, I want you to think of that as a ratio and try to figure out where that ratio comes from. In particular, try to find the angle where that ratio comes from. So I'm going to get into a few basic examples here, and then I think I'll save the more advanced examples for the next video. So I suppose I need to mention one other thing. No, let's look at an example first. So suppose I asked you, what is the inverse sine of -1/2? Right? Now think about what this means. What this means is the ratio of sine is -1/2. And I'm asking you, what is the angle that causes that to happen? Okay. So we're going to think about our unit circle, and we're going to remember that if the sine ratio is -1/2, that means the y value is -1/2. So you can sort of imagine on your unit circle, where do you find a value of -1/2? Where would you find a y value of -1/2? And the idea is, well, -1/2 y is here. That would happen over here. and also over here. And in terms of math, this is a little bit problematic because there appear to be two different angles where this happens. And we like functions. We like to have only one answer when we do things. And so this is where principal values enter the equation, right? I'm supposed to be able to figure out which one of these it is. I'm going to just go ahead and answer this question now. For the case of sine, the one that we want to use is this one. And you might be thinking about that angle as going all the way around and saying that it's 11 pi over 6. The one we're actually going to want to use is negative pi over 6. So this answer is negative pi over 6. Now, how did I know that? Principal values are how I knew that. And so that's what I'll write down next. So principal values. And what are principal values? They're basically a definition of which answer you should use when you're doing inverse functions. And so when you are doing inverse sine, or inverse tangent, or inverse cosecant, you should always be looking in quadrants 1 and 4. And your answers should always be between negative pi over 2 and pi over 2, right? So for those three trig functions, you will always be looking at quadrants 1 and 4, and your answers are always between negative pi over 2 and pi over 2. For the other trig functions, for inverse cosine, for inverse cotangent, and for inverse secant, you will always be looking in quadrants 1 and 2, and your answers will always be between 0 and pi. Right? So to be honest, this is just information that you need to memorize. I don't have a whole lot of great tricks for helping you to remember that. The one thing I will say is that in my mind, all of these are primarily about sine. So this function is sine. This function here, remember that tangent is sine over cosine. So I feel like sine is the predominant function there, and cosecant is 1 over sine, right? Down below, it's cosine. Cotangent is cosine over sine, so there cosine is the predominant function, and secant is 1 over cosine. So again, cosine is the function that's sort of defining everything happening for the bottom ones. Sine is the function defining all the things that are happening for the top ones. So now that we have these things, I've got 3 examples lined up, so let's tackle those 3 examples. Okay. So my first example is what is the inverse cosine of negative square root of 2 over 2? Right? So how does this work, sort of stepwise? I'm trying to decide if I want to draw these steps out. I'll just say them out loud. Step 1, draw the unit circle. Great. Step 2, narrow your field of view. And what I mean by that is, this problem says inverse cosine. That means you should be only looking in quadrants 1 and 2. That's where you're going to find the thing that you're looking for. Don't look at the entire unit circle. Only look where this function tells you to look. All right, so we've drawn the unit circle. We've narrowed our field of vision. The next thing we need to do is we need to locate that ratio, right? So because cosine is an x value, I'm looking for an x value of negative root 2 over 2, right? Now remember from before, the only options for these values were 0, 1/2, root 2 over 2, root 3 over 2, and 1. Right? So the root 2 over 2 value is sort of the middle value. So if I'm looking for an x value of negative root 2 over 2, you know, this is negative 1/2, this is negative root 2 over 2, this is negative root 3 over 2, that's 0, that's negative 1. The one I'm looking for is right here. So the angle I'm looking for must be that one right there. Right? So now I just need to remember what that angle is. And I, continue to see this as fractions. This is pi over 4, this is 2 pi over 4, this is 3 pi over 4. And so that gets us that this is 3 pi over 4. And that's it. And that's how inverse trig works. Let's look at another one. What about, and this one's going to be a little bit more complicated, what about the inverse tangent of negative root 3? Okay, well, let's follow the same steps we did last time. Step 1, draw or visualize the unit circle. In the beginning, it's always going to be draw. When you get better, you can just visualize the thing. So there we go. Step 2, narrow your field of view. Right? Where do I look for tangent values? Well, if you remember your principal values, tangent is in quadrants 1 and 4. So I'm going to be looking over here. Okay. Next up, where am I going to find a tangent value that's negative? Right? Remember that the tangent is sine over cosine. So if I choose sine and cosine up here, they're both going to be positive. I'm really looking for something down here, right? And in particular, what I need is sine of something over cosine of something to be negative root 3. So this is sort of, for me, where I start just thinking about the angles I could pick here. I could pick this angle, I could pick this angle, or I could pick this angle. I mean, I could pick these ones, but it turns out these ones are either 0 or undefined, so it's going to be one of the ones in the middle. So you can sort of imagine, like, well, if I were to pick this one here, the sine value is 1/2, and the cosine value is root 3 over 2. That would give me 1/2 over root 3 over 2. If I multiplied by 2, those would cancel. But in short, I'm going to end up with a 1 over root 3, which is not what I'm looking for. So the angle I'm looking for must be this one here. It must be this negative pi over 3. Now why is that? Well, that's because the sine value there is negative root 3 over 2. The cosine value here is positive 1/2. And when I multiply top and bottom by 2, I end up with a negative root 3 that I wanted. So the angle I'm looking for here is pi over 3. The tangent, secant, and cosecant ones are a lot more difficult. Those take a lot of practice to get quick at. I know we're already long in the video. If you need one more example, I've got one more lined up for you, so I'll show you that one now. Let's see. So the last one I had planned was cosecant, inverse cosecant of 2. All right, so again, visualize the unit circle. Next, to narrow our field of view, where do we look for cosecant? Well, remember that cosecant is 1 over sine. And the sine ones are always quadrants 1 and 4. So I'm looking there. And really what this problem means is it means 1 over the sine of something equals 2. Right? So a sneaky thing you can do here is you can actually say, well, that would mean that the sine is 1/2. So your job here, and remember from the beginning of the lesson, when somebody says inverse cosine of something, it means they're giving you the ratio, and they want to know what the angle is that causes that. So really, I'm looking for what angle gives me a cosecant of 2. What angle gives me a sine of 1/2? So where do I find a y value of 1/2? Well, a positive y value of 1/2 would be right here. That's the short value. So that's the angle I'm looking for. Turns out that happens at pi over 6. Okay. Hope that made sense. I know that was a long video, but if you've always needed to understand inverse trig functions, I hope that helps. And if it doesn't, let me know. I would love to remake a video that works right and shows people how this works. So I hope that got you through it.